Hi everyone. This is my final that explains my visual unit plan for the Waves and Energy unit. This is intended for 8th grade science classes, and the main concepts that it goes over are properties of waves, the electromagnetic spectrum, behaviors of light, and methods of heat transfer. So there are a few different visualization tech tools that we will use in this unit. The first is NearPod. So through this particular NearPod presentation, it is going to be student-paced, so students can work at their own pace that works best for them. Within this presentation, there's also a step-by-step breakdown of how to draw a mathematical model of a wave, so with a specific amplitude, wavelength, things of that nature. It also allows students to actually practice drawing waves. And this is particularly helpful for the teacher because they will be able to monitor student progress and see their actual drawings of those models in real time. So it can allow for remediation when needed or identifying areas where students seem to be struggling. Another tool that will be used is AweApp, which is a visual whiteboard. And we would use this in a way for students to make models based on data that they're presented in class. So for this specific example, students will be drawing their own models that show which electromagnetic radiation from the sun actually reaches Earth. Right? And lastly is Goose Chase, and I like Goose Chase a lot because it's a fun way for students to stay engaged, whether they are at school or at home. So this Goose Chase is kind of like a scavenger hunt for students. So for this one, I'm having students find examples of the different behaviors of light. So finding examples where light is being transmitted, reflected, and absorbed. And to do this, they can record their findings through a video and kind of give an explanation of how light is behaving in each of their findings. The unit is going to come to a close through the solar cooker design project. And this project is great because it allows students to combine their knowledge of behaviors of light and methods of heat transfer all in one project. So there's two components to this project. The first is the organizer document, right? And this organizer document basically highlights the task that students are trying to do. Students will be using Tinkercad to create a three-dimensional model for their solar cooker design. They would take a screenshot of their Tinkercad models and then just add it in this Google drawing that's already embedded in the document. The document also has a report organizer that kind of highlights how the behaviors of light will work in their solar cooker and methods of heat transfer, and basically allows them to explain why their solar cooker will be effective. The second part of this project is going to be a presentation. So students will have 4 different options for presenting their solar cooker. The first will be through Flipgrid. So for students who want to actually build their solar cooker design, they would record a Flipgrid video that highlights exactly what their design is and why it will be successful. They can also choose to record a video through Screencastify or Loom that explains just their virtual design of their solar cooker. They can choose to create an infographic on Canva that explains their design, as well as create a thing link where they can highlight different aspects of their design and focus on how that aspect allows a solar cooker to be successful. On this last page, I have embedded examples for each of these presentation options. So there's Flipgrid one, Screencastify, infographic, as well as the thing link. And if you hover over each thing link and click, it will give you the little description of how it is successful. So that is my final presentation on the Waves and Energy unit plan.